My name is Frederick Finter, and this is my LAI350 final research presentation on why do students fear mathematics. How did math education look in the past? Prior to 1960, math education was very abstract, focused on teaching a wide variety of basic concepts. Post-1960 to about 1980, the new math movement took hold, narrowing topics and focusing on creating a stronger foundation in math. From 1980 to about 1990, the focus of math education switched yet again, causing an uproar from both parents and mathematicians on account of the scarcity of skills being taught. In more recent years, mathematics education focuses more on a broad variety of topics and developing the necessary skills for post-secondary education. Focus of New York State's Next Generation Math Standards. New York State's Next Generation Standards are a way to provide a more balanced education by exploring topics over a longer period of time and building stronger foundations. The standards remain rigorous by balancing conceptual understanding, procedural skills, and real-world application of those skills. The following video is a clip from Graham Fletcher's video titled "The Progression of Early Numbers and Counting." In the video, he explores the different steps that are required for students to gain early understanding of numbers and counting. In the full video, he lays out the topics and progress that students make as they move through grade levels.
Before we ever get to addition and subtraction, and long before we tackle fractions and decimals, there's so much understanding that needs to take place. So here, I'll try to explain the progression of early number and counting. Well, before students come to us in kindergarten, they begin to see what numbers look like. I mean, literally. Check out these dice. Students know that there's 4, 2, 3, and 5, but they don't know that quantity. They're just simply calling out number names and matching them to what the things look like. They know that we have 3, 3, 5, and 4 on the yellow card. What they're doing is matching a number name to a visual pattern. This is a really big piece, but a lot of kids are able to do this before they come to us in kindergarten. This ability to recognize quantity without counting one-to-one is called subitizing. Some say sub, some say su. I just say it's magic. But here, if we were to show the number 4, a student might say 4. Yes, they know the number name, but if you ask them to prove it, they might count them 1, 3, 9, 7. This is a perceptual subitizer. They cannot explain why it's 4. I think most of us are familiar with the conceptual subitizer that would say 4 because there's 2 and 2 more. In this early trajectory, we're talking about a perceptual subitizer. So as students are working on this idea of subitizing, they're simultaneously building their understanding of more and less. Let's take these two hands, for example. If we were to put some candy in each hand, and then we were to ask a student, which one has more? I think most students are going to say the one on the right has more. And they're able to recognize this because they can visually see and compare the difference. They can't tell you exactly how many more, but that visual representation of more, well, that ties back to what they're doing with subitizing. The students don't need to count to compare the quantities. If we were to take some candies from the right hand, put them in the left hand to where they're equal or almost the same, now we have a need to count.
This video shows the complex steps and processes that go into teaching students counting. This is just a small piece of the K through 5 math curriculum and demonstrates the in-depth foundations that are being built. After getting some background on math education standards and how they've changed over the years, it's time to introduce my research questions. First, math is something that both teachers and students struggle with. Why? Students who struggle with other subjects, like English or science, often struggle because of a specific topic or assignment. It's very rare for a student to struggle with an entire subject area, spanning years of their educational career outside of math. Second, what is math anxiety and what causes it? And lastly, how can we as educators overcome math anxiety and prevent it from manifesting in our students? Why math? Of all the standard subjects in high school curriculum, math is the one that students as well as teachers struggle with the most. As we previously explored, education standards for math undergo radical changes every few years, and often when new standards are introduced, the tools for teachers to implement these new standards are forgotten. Because of this, teachers scramble to adapt their lesson plans, which creates gaps in learning. Another reason students and educators struggle with math is because math is harder to engage with than other subjects. There is little to no class time for students to explore topics in math that interest them. Third, some topics in math are more abstract, and students aren't able to conceptualize them. Additionally, these topics lack real-world usability. For a simple example, if you were to ask students to find the area and perimeter of the shapes that are listed on the slide, they would first ask why. Outside of because you have to know how, there isn't a great answer to this question. And lastly, students develop math anxiety. What is math anxiety and what causes it? Math anxiety is a term used to describe any feelings of anxiety that arise when asked to perform a mathematical task. These tasks should be simple, like typing something into a calculator, or more difficult, like taking an exam. I'm sure we all remember those time multiplication tests in elementary school and how quickly those 60 seconds flew by. These types of tests, as well as dated teaching methods, are all contributing factors to students developing math anxiety. Another reason that students develop math anxiety is because they lack the understanding of why they're being asked to do the task presented to them. We've all heard the phrase, "I'll never have to use this stuff, it doesn't matter." And even though that might not be true, without that crucial understanding, students are left scrambling in the dark for answers. What does math anxiety look like? The symptoms of math anxiety can present themselves both as physical and psychological. Any physical symptom that is associated with anxiety can be associated with math anxiety. Things like lightheadedness, getting clammy hands, or increased heart rate are just a few possible symptoms. The psychological symptoms of math anxiety present themselves in a wide range. On the lower end, something we've all experienced before is getting nervous before taking an exam. On the higher end, some students will completely freeze up and completely forget how to do something that they had known how to do just moments before. When does math anxiety begin to develop? Math anxiety can develop in a student or adult at any age with any type of math. Personally, I didn't develop math anxiety until my junior year of college while taking a course on higher mathematics. Gaps in learning are caused when standards for education change, causing teachers to adapt their lessons and refocus their materials. This shift in focus leaves educators and students with tons of questions and nowhere to find the answer. As these students grow up and become parents, their children have questions that they won't be able to answer, which can be shaking both as a parent and a child. These experiences cause a student to question their abilities as a learner. If mom or dad don't know how to do it, then how am I supposed to know how? These feelings develop into math anxiety, and the cycle continues. How much can math anxiety really impact your life? The primary impact of math anxiety on a student's life is that they will avoid math as much as possible while in secondary education. The long-term impact of math anxiety is that students will avoid programs and majors in STEM because they fear both the prerequisite courses and the math-intensive courses that would be required to graduate from the program. This not only impacts a student's ability to perform in classes, but takes away potential careers and fields of interest. The STEM pipeline. This graphic from a 2016 study shows the number of students enrolled as ninth graders and follows these students through secondary and post-secondary education. As you can see, in 2001, there were 4.01 million students enrolled in high school across the nation. By 2005, there were only 2.8 million on track to graduate. Out of the 1.3 million students who were college ready by the fall, only 278,000 enrolled in a STEM major, which is a significantly small number for such a wide variety of topics included in STEM. Out of these 278,000, only 167,000 graduated from a STEM major. Educators believe that part of the reason for such a significant drop in students is the lack of a strong foundation in fundamental math skills. Preventing and overcoming math anxiety. One of the ways we as educators can help our students overcome math anxiety is to let them know that they're not alone. Educators struggle with things too, and it's important for students to see that. By encouraging students to ask questions, we can help them to get the answers they seek and clear away some of their math anxiety. By giving real-world examples of abstract topics, we bring things into perspective and help students conceptualize problems. By taking the time to ensure that students have a strong foundation in concepts, it builds their confidence and their ability to solve more complex problems. We can prevent math anxiety by creating an inviting classroom environment and allowing our students to have a dedicated class time to work through problems. We can also encourage students to ask questions in class and to not be afraid if the answer is wrong. Everyone makes mistakes. It's how we learn from them that's important. I'd like to go over a brief recap of what we learned. Math education standards are always changing, and these changes cause a disconnect between students and educators. This disconnect causes math anxiety, a type of anxiety that arises within students and adults whenever asked to perform a mathematical task, and drives students away from majors and careers that involve the use of mathematics. To bridge this gap and prevent math anxiety, educators need to change the way that they implement these standards into their classrooms. By putting more emphasis on conceptual understanding and real-world applications, students will engage with the material and not develop those feelings of anxiety towards math. Here's a list of my references.